the next homework check, which will probably be next Friday. Yeah, I don't, that's a good question. I need to figure out when the next homework check is going to be and get a list for you. All right, so today worksheet covers a lot of stuff, and we're going to kind of go a little slow and not get through all of worksheet 6 today and finish it up on Tuesday, partially because I want to revisit what we do so you don't forget everything over the 3-day weekend. We're going to talk about vertex form, which we already did one day on parabolas, but then we're also going to talk about standard form of a parabola and converting from one to the other. Okay, and then you're going to have to eventually find the equation of a parabola given a point. And then you're also, which I don't think we're going to get to today, is to do some graphing on the calculator and solve some, what I like to call throw-up problems, when it says something is accelerating due to gravity. Okay, ready? All right, so this is called polynomial form of a quadratic or even standard form. Okay, I think I'm working now. So we don't have anything nice to be able to graph this. Okay, we could type it in our calculator. Does anybody know how we would find the x-intercepts, the y-intercepts, or the vertex given this cranky form that doesn't have those things? Can we, if we pull out a 2, does it get any nicer? Could we factor it then? Okay. This is now called factored form, but what does that help us find? Not the vertex. It will eventually, but we can find the zeros or the x-intercepts, right? Those are the same thing. The zeros are called the x-intercepts. So where does it equal 0? Okay. There we go. So 3 or -1 would make the x would be the x-intercept. So 3 would make it 0 or -1 would make it 0. When it asks for intercepts, please write them as ordered pairs, okay? How do we find the y-intercept? Anybody remember anything about the y-intercept? What's x on the y-axis? 0. So to find the y-intercept, we're going to set x equal to 0. So if we do that, go up here, we get y equals 2 times 0 squared minus 4 times 0 minus 6, which would be -6. And that was when x was 0. Okay, so 0, -6. I'm just going to put it down here somewhere. All right, parabola is opening which way? Up, and it would be kind of skinny. Whoa, gonna need the big dot theorem here. So this was -1 and +3. I don't care how accurate your graph is. I'm just trying to give us an idea what it looks like. Now, yep, I messed it up already. Because is this the vertex? No. No. I should never have graphed that. Yes, Avon. Okay. Yes. Yes, for the y-intercept, set x equal to 0, okay? Sorry, I was thinking about what I messed up here and took a minute to process your question. Okay, this is not the vertex. We didn't find the vertex yet. Any ideas on how to find the vertex? We're going to talk about the vertex finder recipe. Does anybody remember seeing this? -b over 2a. I know you all learned that in Algebra 2. But there's another way we could find, where's the axis of symmetry if it's crossing x at -1 and it's crossing x at +3? Yeah. If you average those, you get 1. The axis of symmetry has to be going right down here at x equals 1, which is exactly what you would have got here. Can everybody help me check that? What's negative b over 2a? Well, negative b is, opposite of b would be 4, and a was 2 here, so we'd have 2 times 2, so that would be 1, right? So it's the same thing, whether we average the intercepts or we use this formula. All right, so we know the vertex starts at 1. How do we find the y coordinate of the vertex? We plug the 1 back in. So we have 2 times 1 squared minus 4 times 1 minus 6 is square it first and then multiply it by 2. So we get 2 minus 4 minus 6. -8. So down here somewhere, way down here off the bottom of my graph paper, is the vertex at 1, -8. So my parabola went further down past, oh my gosh, that's the worst. Nice. Okay, video, be prepared. That is not really looking like a parabola. One side looks like a line even. Oh, I should fix that, but I'm not going to. All right. Oh, life got easier. Maybe. Some things are easier anyway. What's easier on this one? The vertex. Where's the vertex at? -5, -4. So vertex form, maybe we should write up here, is ax minus h squared plus k, so that we know the general form. The last one was just ax squared plus bx plus c. All right. Can we find anything else? Somewhere over here. This graph is pretty ridiculous, but how do we find the x-intercepts and the y-intercepts? X equals 0, we'll find which one? The y-intercept. Okay, so if I put a 0 in, I'd have -3 times 0 plus 5 squared minus 4. That would be 25 times -3. I got -79. That's a beautiful number. Anybody else get 0, -79, or did I do something crazy? Anybody use their calculator? Okay, so I'm going to call this spot right here -5, -4. Does this parabola go up or down? You already knew that because of this 3, right? Well, it crosses over here somewhere, way down here at -79. Okay, what do you think our x-intercepts are going to be? Is it going to cross the x-axis? No. Okay, let me show you algebraically. This is when you put in y equals 0, right? How would you solve that using your algebra brain? Add the 4, do not distribute. And distribute. We divide, right? And then we'd square root, and how's that looking? We got imaginary numbers, right? So that's why it doesn't ever cross the x. There are no real zeros. All right, moving on. This one is called factored form, and we kind of cheated and already used factored form earlier, right? What were the hints we used for factored form? The x-intercepts are also called the zeros, so they exist at, nope. Well, when y is 0. So set this equal to 0, and where would they be? 5 and -3. The y-intercept is when x equals 0, right? So if I put a 0 in here and a 0 in here, I will have 1/2 times -5 times 3, which is what, -7.5? Is that close enough? So I have 5, -3, -7.5. How do I find the vertex? Okay, that would be an easy way in my mind. Yep. -3 plus, that was a 5, right? I can't read my own writing. Is 2 divided by 2 is 1 again. So the vertex is at 1 something. How do I find the y coordinate? Yes, plug the 1 back in. So 1/2 of 1 minus 5 and 1 plus 3. -8, anybody? So just a little bit below our y-intercept was where it had a vertex. And where the axis of symmetry would go through. What's the equation for the axis of symmetry here? Okay, but that would be harder to find because we'd have to FOIL it back together. Anybody else? Idea on how to find the equation of that axis of symmetry? It's a vertical line that goes through the vertex. Come on, somebody's awake. Every vertical line has an equation what? X equals, Miss Hoffbauer, yes, it's a vertical line, X equals. And what point does it go through? The vertex, 1/8. So the equation for the axis of symmetry would just be X equals 1. Goodness, are we all sleeping? Okay. So changing forms from one to the other, okay, is a little bit tricky. We're going to practice this. The first one says change this to x-intercept form. What was x-intercept form again? It was basically factored, yes? So it's also called factored form. So can you factor this one for me? How is this going to factor? Yeah, some of you are really struggling with the factoring thing. The back number has to multiply to make 5. There aren't very many choices. Okay, 5 and 1, and to multiply to make a positive 5, they either need to be both positive or both negative. But to add up to be -6, they are both negative. Everybody good? Okay, change to vertex form. All right, to change to vertex form, you could complete the square, or you could use the vertex finder recipe. I'm going to show you completing the square, okay? On this one, because we're going to practice this a whole bunch today. So I'm going to move the 1 over to the other side with the y. And then I'm going to put a blank on there. Most of you are going to not choose to use completing the square. I'm telling you right now. So I'm going to show you other way that you'll like better. Well, let's just practice this once. Now, if we want to complete the square on this side, some of you got a little foggy on this yesterday. What are the rules? Half of this. So this becomes x minus 2. Tristan, you with us? Half of this is -2. then we square that. X minus 2 times x minus 2 is x squared minus 4x plus 4. What we did to that side, we have to do to this side. So what's left on this side now? Y plus 3. Okay, how could we make that vertex form? Just subtract the 3 over to the other side. So this is now vertex form, where the vertex is at 2, -3, right? All right. I'm going to show you this one more time, and then I'm going to show you a way you'll like better, okay? I'm going to show you one that has a 2 out here. It's not fun. First of all, we're going to subtract the 7 to the other side and put the blank in. But we don't know how to do completing the square when there's a 2 out front. So could we factor the 2 out of those? Just the 2, though. So then it'll say x squared minus 6x, and then I'm going to put my blank in there. I hope you can just be following me, okay? I'm not saying we're going to have to do them this way. Eventually, you are going to have to do, second semester, a whole bunch of completing the square when there's a coefficient other than 1. All right, so help me complete the square within the parenthesis here. It becomes x minus 3, and we square it and get 9. But does anybody know what we have to add to the other side? Yes. Because of this 2, when we put a 9 in here, we really added 18 to this side. So we have to add 18 to this side. Now, that gives us y plus 11 over there. Oh, I can't lose the 2. There's still a 2 out there. And then we would do what? Subtract the 11. So we'd have y equals 2, x minus 3 squared minus 11. Okay, can I show you my other method? Okay. Everybody ready? The other method is to use the vertex finder method, negative b over 2a. Can you go back to this equation right here and tell me what is the opposite of b? 12. And a is 2. So we'd have 2 times 2 or 4 in the denominator, and 12 divided by 4 would be 3. That means the vertex is 3 something. Okay. To find the other part of the vertex, what do I do with that 3? Yes, I have to plug it back in here. Warm up your calculator here, guys. 2 times 3 squared minus 12 times 3 plus 7. Should be negative 11. Negative 11, okay. So now I knew the vertex. Could I have just plugged it into the form? The 3 and the negative 11? What's the number that I also have to remember, though, to finish this? The stretch still stays the same. Do you notice? Let me write this form. This is what we started with. And this is what we ended with. Right? What's the same in both of those equations besides the x and the y? The a stays the same. So this stretch of 2 is still there. Okay? Now, you're thinking, I don't get what she did. I have no idea. We're going to practice right now. Let's do C right here. We'll go back and do the other ones in a second. But I want to just talk about C. I want to get this in vertex form. I'm going to use x equals the opposite of b over 2a, which will be positive what? Positive 6 over 2 times 2, or 4, What is 6 over 4 reduced to? 3/2, or I'd even take 1.5 because it's exact, okay? Now we have to plug it back in to find the y value of our vertex. So we're going to say y equals 2 times 3/2 squared minus 6 times 3/2 plus 13. Okay, got a calculator. You will actually have your graphing calculator on this question when it comes time for the quiz. Next Friday's quiz is still no graphing calculator though. All right, 2 parentheses 3 divided by 2 parentheses squared minus 6 parentheses 3 divided by 2 parentheses plus 13, 8.5 or 7/2. 17/2, did I say? Okay. Now, what we were finding, remember, was the vertex. So the vertex is at 3/2 and 17/2, or I would be okay if you use decimals because they're exact. Okay, so can anybody write the equation in vertex form now? Y equals, what goes in front of the parenthesis? The A, which is, and then it's x minus h, which would be, yep, these are h and k, squared plus k, which is, good job. All right, what does it say? We need to identify the vertex, yes? So the vertex was here, we already got that. And then it said sketch, oh, the axis of symmetry. X equals, do you remember the axis of symmetry? X equals what? 3/2. Okay, the axis of symmetry, here, axis of symmetry is always x equals h, or negative b over 2a. And which way is this one going to open? All right. So let's go back and do a couple easy ones to tie this together. What's happening on A? Okay.
Oh.
Yeah, what are we trying to do? Identify the vertex, the line of symmetry, and the opening direction. Yeah, we can do all that right now. Where's the vertex? 5, 6. What is the axis of symmetry? X equals 5. It needs an equation. And it opens. Uppens. Oh my goodness. It opens up. I just made a new word. It uppens. Now, if we had to find the other form, we would have to FOIL this out and distribute and add 6 to get it back to polynomial form. Thankfully, it didn't ask us to do that. All right, so B is equally easy. Can you give me all the information for B? Vertex is -3, 7. The axis of symmetry is x equals -3. Guys, it has to be an equation. If you just write -3 on a quiz, it's going to be wrong because it is a whole line, okay? It's not some single dot. And it opens down because of what? Yes. Oh my goodness. I can't. All right. Good so far? All right, let's go back and do it. Let's do one of these and save one from Tuesday for a warm up, okay? Which one do you want to do today? E? Okay, what are A, B, and C? And should we just rewrite it? 5x squared minus 6x plus 12. Can you tell me any of the things we want to know right now? Yep. Which way does it open? Yeah, it opens up because of the positive 5, right? So that's one of the things we wanted to know. We're supposed to find the vertex and axis of symmetry. Anybody want to complete the square for fun? And try to divide a 5 out of a 6 and use fractions? No, I don't think so. Do you remember another way to find the vertex? Opposite of b over 2a. Good job. So we would have positive 6 over 2 times 5, which would be 10, which would reduce to 3/5. Yeah, we picked another icky one, but we can do this. So the vertex is going to be 3/5 something, right? How do we find the other piece? All right, so it's 12 minus 6 times 3/5 plus 5 times 3/5 squared. I don't think I want to do that in my head. It's 51 over 5. I did do that in my head. I got 51 over 5. Okay. What else did it ask for? Oh, axis of symmetry, right? Which would be x equals 3/5. All right. It didn't ask for this, but can you help me just because I want to practice? Can we write it in vertex form now? Y equals oh yeah, there would be the stretch out in front. Good job. The stretch still stays there, right? But then it'd be x minus 3/5 quantity squared plus 51 over 5. Everybody okay? Because you're going to have to be able to go back and forth that way. All right. One more idea today. I'm going to do a couple of these to find the equation for a vertex. And I gave you a hint here. It says start with vertex form, and then you need to find the stretch A. This should be kind of A in quotes. And this should be by putting in, not but putting in. By putting in another point and solving for that A value. All right. Students who just think they're going to do this, finding the A by guess and check, struggle the whole rest of the year because we use this same exact concept to find equations of cubics, equations of square roots, equations of polynomial functions. Okay, so please don't ignore me and just think I can do this. We're going to pick the vertex and then start with vertex form. It would be y equals a. What is this ordered pair? According to these little tick marks here, I would go with 2, 1, yes? So the equation is going to be x minus 2 squared plus 1. All right. This idea of plugging in another ordered pair to solve for A is what you have to get used to because we do it over and over the whole year. All right, so find us another ordered pair on this. Yeesh. I think we could go with 1, 2. Okay. On a quiz, I would give you clearly marked ordered pairs. So now we're going to put x is 1 and y is 2 into this equation here. So it'll say 2 equals a times 1 minus 2 squared plus 1. Okay. Now, students get a little crazy at this point and try to simplify all this. But this is multiplied together, right? So don't do anything with that 1 yet. 1 minus 2 is -1, but when you square it, you get what? So we have 1a plus 1. This one's pretty tricky. If we subtract, we just get what? We subtract 1 from each side, we get 1a equals 1, or a is 1. So there really was no stretch here. It was 1x minus 2 squared plus 1 was the equation of the parabola, and you don't have to have the 1 out front. All right. So how did we start? The vertex. What is this vertex right here? Ooh, don't use that color hotbar. Can't see it. 2, 3. Okay, and let's think ahead. What do you want to call this maybe point right here? Yes, thank you. Somebody fix me. -2, 3. And this point right here would be -1, 0. Okay. So we're going to put these in for h and k because it's the vertex. And then eventually we're going to put those in for x and y. But let's start by writing the vertex form so you're not confused. Y equals, we don't know a. Just a minute. We don't know a yet. Then it goes x, what? X minus h, but be careful. Remember, this was supposed to be a -2, so it's +2. Plus k, which is 3. Okay. Then we go back and put in another point, which is where we're going to use this x and this y. So we're going to put those in here. 0 equals a times -1 plus 2 squared plus 3. Be real careful that you don't do something crazy over here. It's a times what? -1 plus 2 squared would be 1 squared, which would be 1. So how do we get the a by itself? So we get -3 equals a. So I knew it was going to be negative. Did you know it was going to be negative? Yeah. Because it was opening down, right? But I couldn't tell how skinny or narrow it was till I found this. All right, so it should be y equals -3x plus 2 squared plus 3. I just put this back in here. Whoops, kidding. For the a. Here. Okay, I just lost my. I put it back in there to get this equation. All right, last one for the day. Do you want to do D or E? Let's do E, okay. So, same question, we just don't have a picture. What are we going to start with? Yep, this is the vertex, so this is an H and a K. So y equals some stretch times what? X minus 2 squared plus 5. Now, substitute in the x and the y of the other ordered pair. Guys, it doesn't work to put the vertex back in because we're trying to find the stretch. Is there any stretch going on at the vertex? No. Another point has to be put in to find the stretch A. So if we put in y is 6 and x is 4, we'd get this. So we'd have 6 equals what a plus 5? What goes in front of here? 4 minus 2 is 2 squared is 4. Okay, so now what? Subtract the 5. And we get a is 1/4. So what's the equation? 1/4 x minus 2 squared plus 5. Okay. I'm going to take out my graphing calculator. I just want to show you this. And I'm going to graph 1/4. I'm going to cheat and put 0.25. X minus 2 Quantity squared plus 5. What 2 points is it supposed to go through? What did we start with? 2, 5. So if I do trace 2, I get 5, right? It's working. And the other point is, so if I go to 4, it's supposed to tell me it's at 6. Is it working? Yeah, it's really hard to see for the rest of you. I'm weren't in the front of the room. Okay. I need somebody really quick to show me worksheet, the next one, the homework one. 7. Okay. Because I'm worried that we need to not do all of them. I want to be able to tell you which, you have 7 real quick? Which ones of these you're ready for, okay? So is that what, does anybody have their blue sheet out? Is that what it says on the blue sheet? 1, 6, 7, 11, 14, 15, and 16? Okay, I'm going to change this. I want you tonight to do, whoa, maybe I should turn my tablet the right way. Okay, I want to do 2 and 6 would be good. And 7 and 11 would be fine. Uh, 14 will be a challenge, but look at 14, and that's it. Okay, these 5 questions. 2, 6, 7, 11, and 14. Thank you. All right. Other than that, remediation is in the bucket. If you need to be practicing something to be ready for the quiz next time.